Hello and welcome to Homework 6. Hopefully you found everything okay. We do more and more of these all the time. This time what we're going to start focusing on is proportional relationships, okay, which is really the heart of this unit. Okay, this is where things really start picking up and we use all those skills that we learned in 6th grade to really dive into some of these topics. Okay, so our goal this time is to identify a proportional relationship or a direct proportion in a table. Okay, and we'll focus on equations and graphs as we go, but starting with tables. Okay, so what we have here is a table, and you'll notice off to the side I've kind of put this thinking bubble, and I just want to point out to you that for a lot of this packet you're going to see these horizontal tables. And in a horizontal table, they usually label X and Y, but sometimes they use other letters. So we always want to assume that X is on top and Y is on bottom, unless stated otherwise. Okay, so someone's allowed to switch it, and if they label it, that's fine. Otherwise, we assume X is on the top, Y is on the bottom. And then for a vertical table, we always assume that X is on the left and Y is on the right. Kind of just makes sense, just like the alphabet. X always comes first. It's the one that you read first, unless otherwise stated. Okay, so in this table, luckily, they've labeled X and Y for us. Okay, these are all of our X values and then all of our Y values. And the first thing we're going to do is for each pair of X and Y values, okay, so this pair, this pair, this pair, and this pair, we're going to find the fraction or the ratio Y over X. Okay, so very simple. This first pair, the Y value is 2, the X is 1. We have 2 over 1, which is 2. The next pair, we have 4 over 2. 4 divided by 2 is 2. The next one, we have 6 over 3, which is 2. And lastly, 32 over 16 is 2. So what are you noticing? Hopefully you're noticing that they are all equivalent. Okay, and when you have this fraction, this ratio of Y over X, where each pair has an equivalent value, okay, so you notice these all equal 2, we say that this is a proportional relationship. Okay, and this leads to some really important things. So if Y over X equals this constant number, okay, we're going to call it K, this same value over and over and over again, then we can say that Y is directly proportional to X. And when that happens, that constant value, that K, is what we call the constant of proportionality. Okay, constant of proportionality, which is kind of a funny phrase, but very, very important. Okay, so based on the chart above, could we say that Y is proportional to X? Meaning, when we did Y over X, Y over X, Y over X, Y over X, did we get the same constant value every time? The answer is yes, right? It equaled 2 every single time. Because it equaled 2 every single time, we say that our constant of proportionality equals 2. We say that K equals 2. Go ahead and pause, jot down any questions you have, catch up, listen to it one more time, make sure you understand. It's very, very important. And then what I want you to do is this practice problem, and there's one on the next page. Okay, and when you're done trying it on your own, you can resume the video and I'll go over it with you to make sure that you understand. Okay, hopefully you took the time to pause, try it on your own, and now you're coming back to see how you did. For this one, okay, when we do Y over X, we're getting 100 over 2, which equals 50. Then we have 150 over 3, and 150 divided by 3 is 50. And then our last pair of y over x is 200 divided by 4, which equals 50. So did every ratio, every fraction of y over x equal the same constant value? The answer here is yes. So we would say that y is proportional to x. Okay, this is a proportional relationship. And we would say that k equals 50. On the next page, we have another example here. And again, every single time, it's always, 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 always y over x. And unfortunately, every year I have students who want to do x over y, and it's just something you really have to memorize, y over x. Okay, so for this first one, 15 over 1 equals 15. Next pair, 30 divided by 2 equals 15. And then lastly, 50 divided by 3 is not equal to 15. Okay, you can double check that on your calculator, absolutely. But because each value, each fraction of y over x is not constant, we would say no, this is not a proportional relationship. Therefore, there is no constant of proportionality. Go ahead and pause, jot down any questions you might have, and we're going to move on to the next section. Okay, for this section, we're going to connect what we just learned to some equations. Okay, and there is just one minor typo. Can you change that 21 to a 27, please? And now everything will work out just how we want. Okay, so this example here says the table shows the distance traveled by a snail, d centimeters, after t hours. Tell whether d is directly proportional to t. Okay, and because they wrote d first and t second, that's the same as when they say y is proportional to x. So this time we're looking at d over t. So be very careful with that. It says, if so, give the constant of proportionality. Okay, so they want us to find k if this is proportional and tell what it represents. Okay, then write an equation. So there's a lot going on here. Okay, we're going to start by figuring out if this is a proportional relationship, if d over t is equivalent. Okay, so our first pair of d over t is 9 over 1, which equals 9. The next pair is 18 divided by 2, which equals 9. And lastly, 27 divided by 3 equals 9. Okay, so based on this chart, we would say yes, d is proportional to t. And because it's proportional, we have a constant of proportionality, which in this case is 9, because that's the constant number we got every time. What does this represent in this situation? Okay, whenever you get that question, it shows up on tests a lot where they want to ask, you know, what does this represent in the situation, or what does it represent in the context of the question? They're asking you to connect the math back to the word problem. So what was this problem talking about? It's talking about a snail traveling over a certain number of hours. Okay, so this 9 represents the fact that the snail travels 9 centimeters per hour. I want you to pause right there. Think that over. 9 centimeters per 1 hour. If you remember back about a week ago, we talked about unit rates. Okay, the rate per 1 unit. Wouldn't you say this is the same thing as a unit rate? How much is traveled per 1 hour? This is very, 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 very important for you to understand that the constant of proportionality is really the same thing as unit rate. Okay, so those two facts are going to help you as we move on in this unit. And the last thing they asked us for was an equation. And this is something that you gotta know. If you have a proportional relationship, we can write an equation in the form y equals kx. And the only thing you have to do is substitute in the k. So if you look back up here, what did k equal? K equaled 9. So we would say y equals 9x. All I did was change that k to a 9. There's a lot of steps there, but hopefully not too bad. If you flip to the next page, you'll see that you have 2 practice problems, and I do want you to try those on your own, and I'll give you the answer key tomorrow. Write down any questions you had, rewind, rewatch. Good luck!